So thanks for coming. We're doing, yeah. Better? Okay. So we're doing a workshop called Prevent First, Detect Second. Let us introduce ourselves. I'm Sagi Dulce. I'm a VP of Research in a company called Zero Networks, working in the Zero Labs team and the research team of the Zero Networks. I've been doing security research for the past 15 plus years, mainly in defensive type of research. For a few years, I like switch side from the vendor side. I went to like the client side, working in large pharmaceutical companies, trying to understand how we can better defend them. And I think this is also part of the instigator for this talk. As defenders, we felt like there's a lot of missing pieces, missing tools out there that we wanted to use. And in the last few years, we've been running a lot of open source tools. So some of them we'll be talking about here. So that's kind of the background of how we came to this talk.
Hey, I'm Deco. I've also been in the IT and security field for around 15 years. I've been kind of both sides of the fence. I started on more the offensive side, doing penetration testing, developing attack tools, all of the things. Later on, I've moved more to the defensive side, both from startup companies and large enterprise, doing defensive work. Yeah, and a lot of what we're going to talk about is based on our own pains, trying to prevent attacks on things like Active Directory and the domain controller, where it's really hard to lock it down because it has to stay open.
Cool. More? No. Better? More? Everybody can hear us? Great. Okay, so what are we going to do today? We're going to start with some theory. So bear with us. We're going to sort of explain our perspective about detection and prevention, advantages and disadvantages. And then we're going to start like from the end. We're going to show you what's the end goal, at least from our perspective, like what we're trying to achieve. We're trying to achieve an Active Directory, very well protected, so you can just stop a whole bunch of attacks, like on that PC. Then we'll take a step back. We'll talk about protocols that we were discussing. We'll talk about LDAP. We'll talk about PC. We'll talk about the attack vectors that they expose. We'll do a deep dive into all the different tools, the LDAP firewall, the RPC firewall, how you set it up, how you configure it, and how you achieve the best prevention that you can. And then we'll take a look at the bigger picture and try to understand like what's our end goal and how we can achieve this in production. So we start with motivation. I said a little bit earlier, if you already have, I assume most of you don't have, which is fine. We do a lot of demos. It's going to be a lot of hands-on. If you do have a VM and you want to start with installing, you have like a disk running on it, that's perfect. You can follow along. If not, don't worry about it. So let's start with a little bit of the why. Like, what's the issues with detection? How many of you guys are like doing detection engineering in general? Nobody or somebody? Great. So we're going to start with a little bit of provocation. Like we also sort of did detection engineering, sort of. And a lot of times we thought, is it really worth the effort and the investment? And there are some issues with it. One of the issues is the trustworthiness of the data. Like in a lot of cases, you're sort of relying on already compromised assets. If it's EDR, which can be bypassed or shut down. If you have a network tap, maybe somebody already impersonated that IP and you think an attack is coming from one host when actually it's another host. If it's all sorts of way to bypass the Windows event mechanism, if it's unmanaged asset. So there's a lot of problem trying to gather a lot of different log sources, correlate them. They can be very, very unreliable. Another maybe obvious problem with detection is that maybe it's too late. I think this is coming from the CrowdStrike report of last year, saying that by the time you get initial access to the adversary trying to move it around in your network is an average of 84 minutes. And I assume that like 99% or 99.9% of companies, even if that's the number, it's very challenging to meet. Like, can you really isolate and stop an attack in an hour, in 2 hours even, or even in a day? It can be challenging to a lot of security companies, especially if it's a large environment. And the entire mind frame mindset of I gotta catch them all, I gotta go after the 400 and something enterprise technique, and you have to multiply it because one technique you need maybe 10 detections just to catch that one technique. And if you have to maintain 1,000, 2,000 detection in your environment, it just doesn't scale. It's very hard to maintain, and it can become a huge hassle. On the other hand, if you're more prevention focused, maybe maybe you don't need to detect everything. DLA injection, who cares? Like, do you really need to find DLA injection in your entire environment? Do you really need to find credential dumping? Can you? Are your detections good enough to find credential dumping across the board? And if so, all the different variations. And if so, the machine is already compromised. Should you really invest your time and energy? I would argue maybe not. So that's the advantages of prevention. Just like, let's focus on what we can stop and maybe not focus so much on the things that we can stop. Another advantage is this concept of self-defense. Like, it makes the world even simpler. You can look at your environment as I have clean assets, or I'm pretty sure those are clean assets, and the other ones could be compromised. And I need to defend my clean assets from the compromised one. Those are the only ones that I can trust. And maybe the most obvious advantage of prevention is if in detection you're always at least one step behind, in prevention you could be one step ahead. Your attacker is already frustrated, you already stopped some attacks. Now the advantage goes to you, so you can go ahead and isolate this attack. And maybe to best drive this point home is when you look at Active Directory, it's your most exposed asset in your environment. Even if you can firewall RDP and PowerShell, RPC you have to have open, LDAP you have to have open, DNS you have to have on a bunch of other ports. So if you're detecting an attack on Active Directory, you're already too late. Like, if somebody used the coercion attack or did an NTLM relay, they're already doing it. You already lost the game. So if you're going to use prevention, Active Directory like the most common sense place to start. Okay, so let's start from the end. Let's see what our end goal is in this demo. So we're going to show our lab, basically. I'm not sure I'm going to do the demo with the microphone because I haven't hold it. So let's
me too.
You can, or you can do like an interview style. So we have basically a domain controller. We already have the RPC firewall and the other firewall installed. It's already configured for like maximum efficiency or very high efficiency. And we just want to drive, this demo will be a lot of name dropping of different tools and different attacks. Hopefully you know most of them, or if not all of them, just to drive the point home of what you can achieve if you use these tools. So that's what I want to show now. Yes, that's what I said earlier. So we show a bunch of LDAP attacks, a bunch of RPC attacks. It's going to be a little bit of all over the place, but it's about sort of showing quantity. So we have here, you can see I have a, how do I minimize this thing?
No.
Okay. Okay. So we have here an Active Directory. So we have here in the Active Directory. We already downloaded and installed the RPC firewall, the other firewall. We're not showing this now, we'll show it later, so don't worry about it. So we have those tools installed. So you see we have them installed. You see this big configuration file. It's very confusing, but don't worry about it. It just means that everything's there, it's running. We have the other firewall running as well. A little bit more elegant, just saying that it's installed. That's our victim, that's our Active Directory. This is what we're going to attack. Here we have like a nice convention. I have all the attacks in the back, you can see, don't worry about it. And we're going to run a bunch of attacks. I'll assume you are familiar with some, if not most of them. Sharphound, I assume you are familiar with Sharphound. A lot have connections, let's see, Nottingham, yeah. So I'm going to run Sharphound. I'm running this, by the way, with domain admin credentials, so I should have like maximum access to the domain controller. I'm running Sharphound, which should work against the domain controller. This is just like the default configuration. And you'll notice I get like nothing back. Like if I'm an attacker, I'll already in the environment running Sharphound just to like get a feeling how many computers, how many users, what's like the relationship. Nothing, nada. Already good news for the defenders. Like the attackers are already a little bit frustrated. Okay, so I couldn't run Sharphound. Let's run like a Kerber roasting attack. I assume you're familiar with Kerber roasting. I'm trying to figure out which users in their environment are Kerber roastable. So I'm running this in-packet script called get SPNs, get user SPNs, trying to understand which users in their environment I can run Kerber's attack against. So I'm running Kerberos, I'm trying to get SPNs, no one is found. Again, kind of frustrating. I got nothing, annoying for an attacker, good for a defender. And I know there's at least one Kerberostable user in this. So that's another annoying thing. What I'm going to try to do next is run a targeted Kerberosting attack. So try to create an SPN for the user and use that SPN to request a ticket and run the Kerberos attack again. I'm going to do it on PowerShell. Or you So again, I'm domain admin. I should have the privilege to do that. I'm trying to create a Kerberostable an SPN to make it for the user. I get access denied. I'm domain admin, I get access denied. Really, really annoying. Okay. So let's try to create a GPO. Let's try, if I'm domain admin, I can create a GPO and have everybody executing code. Great. I'm going to try to run a GPO. I get access denied. Really annoying. Okay, let's do another thing. I'm going to run Coercer. I don't know how many of you guys know Coercer. It's a RPC-based attack trying to force an MTLM relay from the domain control to other locations. And it's doing it on a bunch of different RPC interfaces. So it's doing, I don't know how many, like 5 or 6 or 7 different interfaces. I get a lot of different responses. They all have one thing in common. I don't know if you can see it. They all say access denied. Again, I'm a domain controller, a domain admin account, I'm trying to run all of these different RPC attacks. Access denied. Really pissing me off. Okay, so now I'm going to run Mimikatz. I would assume that everybody knows Mimikatz. Let's get inside. and I'm trying to run the DC sync attack to get like NTLM hashes. Another popular attack vector. And as you might guess, I'm going to get the same type of error. I got an RPC exception, 5 is access denied. Again, came from Mimikatz. I'm not through. I'm going to run another impact script called @exec. Wait, so @exec schedule test attack. I'm just creating schedule tests and running a new command remotely on the host. Password. And I get access denied. Finally, I'm going to run psexec, which uses the remote service of our RPC to create a remote service around an attack. And as you might guess, I'm going to get the same error. I'm going to get access denied. Access denied. So that's sort of to make you maybe to confuse a little bit, but also to drive the point home that we just ran like 10, 12 different attacks over LDAP, over RPC. Some of them you need domain admin, some of them you don't need domain admin. All of them were blocked, and all of them as an attacker, it's very frustrating and just show you the power. Like if you can block all of these attacks in your environment, an attacker just get frustrated, and then you're one step ahead, you can go ahead, stop their attack. So that's our goal. We're going to show how we're going to get there. How we're going to configure those tools. Those are the RPC firewall. You see them here in the LDAP firewall. How we can configure them and do in production what I did here in like test environment. So all of those attacks and much more will be stopped. So we've done all this crazy command line attacks. Hopefully it was clear enough. But let's take a step back. Let's understand what is happening behind the scenes of our RPC and LDAP. What are those protocols, and what are the attack vectors that they experience? So when I say RPC, like how many people like know what I'm talking about more or less, or very well? Okay, so I know we didn't say it like in the beginning, but feel free to ask questions like on the line, like if I'm doing something too fast or slow. So RPC remote procedure call basically says if a client or in native code, if I want to call a function, I just need to jump to that address. So it's very easy. But if I need to call a function that's in a different process or even on a different machine, that can be more tricky. And that's why we have RPC. It's a way to call a method remotely on another process, and that process can be locally on the same host, or it could be on a different host. And some terminology that relates to RPC that's very, if you don't know it, we'll go over it. So when you're calling a remote function, you need to say what you're doing, who you're calling. And you say that with two things, with the several things, but the most important ones are the UUID. That's like a GUI that identifies the
Topic.
the topic of the RPC calls. So in topic of scheduled task or in topic of printing, you have different functions. And the second thing that you need to say is which function. So it can be function number 0, 1, 2, 3, so on. I need to know which protocol you're using. Are you accessing this function remotely locally, or doing it remotely over TCP, over SMB, over HTTP, and so on? So if you didn't get a chance to like see how that looks like in documentation, let's open up for the printing system RPC protocol. So many protocols that are documented by Microsoft. So you can go ahead, you can see how it looks like, you can read the different functions. If we'll go to standards, we'll get this long UID here. Sorry?
Better? More?
Yeah, thanks. So if you go here, you see this long UUID that's describing, okay, this UUID says we're talking about remote procedure call regarding printing services. That's like the headline. And if you want to say, okay, so now I want to call a specific function, you can go through the protocol details, messages, and then you'll see here, you have different messages and different opnums. So if I'm calling opnum 0, that means I'm calling enum printers. And if I'm calling opnum num 1, I'm calling open, and so on and so forth. And you'll see here you have more than 100 opnums. So just this single RPC interface exposes 100 plus functions multiplied by a few dozens of interfaces that are exposed remotely. You have easily 1,000, 2,000 functions exposed on every server. And if there's a 0-day, it can exploit it, or if there is an attack there, it can also exploit it. So that's basically like how an RPC interface looks like. So it's very, almost every Microsoft services uses RPC. Some of them are used locally just for communication, but a lot of them are also exposed over the network. This could be, like we saw now, for printing, for remote registry, for task scheduling, for authentication, for decom, and on and on and on and on and on. And this is also very convenient for attackers, because if you have this option to call a function on the server, there's a lot of things you can do. You can schedule a task for lateral movement. You can run like the DC sync attack with Mimikat, just like we saw, PSExec attack, certified beyond attacks, a lot of them going over the RPC vector. Petit Patami, if anybody heard, that's like part of the coercion attacks. And there's the occasional, like every 2-3 months, there's an RPC vulnerability. Some of the most famous ones a few years back were print nightmare, zero logon. So it's a huge attack surface just over RPC. And now let's do some LW.
Yeah, so the other side of the coin is LDAP, it's the lightweight directory access protocol. It's an open protocol, can be used in many things, but it's most commonly used in Windows. Easiest way to think of it for me is kind of like database. So you have kind of like you have a SQL database, but that is stored not in tables, but instead is directory format. So you have like your top domain. So let's say company.com. Under that, you can have different folders, which are called organizational units, and you have different objects under that. And what LDAP lets you do is basically query that information. So query meaning you can read that thing, you can search, you can modify, you can add data, you can delete data, and all of that. So if you think, for example, in the Windows environment, if you open your Outlook and you want to search for somebody to send an email to, and I go in the to tab and press S, Control K, and then it shows me that I have Sagi and some other people that starts with the letter S. Behind the scene, that's an LDAP query towards DC that's asking for all of the users that start with the letter S. Another example, when we add a new computer to our domain, behind the scenes, we're creating a add request to add that computer as new object inside our ntds.did file, which is basically our structure for the whole domain. Second. Yeah, and LDAP basically supports a bunch of different operations. So we have search, which is probably the most common, add, modify, delete, and a bunch of other less used operations. So this is an example of what that directory structure actually looks like. So at the top, we have company.com, that's our domain. Under that, in this example, we have a few OUs, which are kind of like a directory again. So in this example, we have an OU for different branches. So we have the London branch, we have the New York branch, Paris branch, and so forth. If you've ever opened the Active Directory using computers, you've probably seen the default OUs. So you have one for users, you have one for computers, things like that. So those are all of OUs. And under that, you have the different objects. So you have the users, the groups, the computers, In this case, if we look at the London branch, we can see a user called John Doe, which is an object of type user. We can see a group, which is an object of type group, and so on and so forth. Now, if we take a look at a specific user, each user, instead of having like a unique identifier or something like that, the way you actually identify a single object is something called at the end, distinguish name. So for me, the easiest way to read these is actually going from right to left instead of left to right. So we can see that we have at the bottom DC equals com, and before that DC equal company. So that's our domain component that basically identifies our top domain top structure. Before that, we have OU equal London, and before that, we have CN, which is common name, John Doe. So basically, this long string says, I'm talking about John Doe, which is under the London organization unit, which is part of the company.com domain. And if we look at a specific object, each object has attributes. Attributes meaning the different fields that hold different data. So in this case, we have a common name, we have first name, last name, telephone number, email. We have object class, which is the type of the object. So I can have user class, but also have group, we can have computer. These are pretty fluid. And if we want to see what it actually looks like in Windows, on the left, we have, again, Active Directory used computers. You can go to the attribute editor and see all of the different attributes, or you can use PowerShell if you prefer. In this case, I'm using get user. It gives me back some of the attributes. You can actually ask it to give you other attributes, and again, behind the scene, LDAP query. And you can do the same for groups and computers and so on. And like RPC, LDAP used a lot in the wild. The problem with LDAP is it always has to be open. There's a lot of sensitive attributes that you can read. So we have, for example, the anti-security descriptor attribute, which is what holds your ACLs, your permissions. So if you've ever used Bloodhound and you've seen all of those edges of this user can change the password of this user, or this user can add other users to the group, things like that. That's all inside these attributes, basically all of your permissions. We have the things like delegation information, ADMPD, W expiration time, which is used for lapse password rotation, and a bunch of other critical attributes. We also, some attacks modify these attributes. So we saw earlier, service principal name, we change SPNs, key credential links, which is used in attacks like shadow credentials, script path, a lot of different things that attackers want to modify remotely in order to do some attack. And also creating new computers. So this is used sometimes in impersonation attacks. So if you want to impersonate another computer, there was this issue a while back where you would create the same name as the computer you wanted to impersonate, just without the trailing $sign, and that would work. Or it just if attackers want to create their own users and stuff like that. Again, popular with a lot of attacks. And a lot of tools, Bloodhound, EasySync, target cover roasting, shadow credentials, a lot of different things. Also, a lot of tools like Parsploit, PowerMed, Packet have different models that you either query or modify or create new objects using LDAP. Okay. I've attached here a bunch of different resources. I'm seeing we're going to share this slide later, probably. If not, you can just come to me and I'll give you the links. Basically, a lot of articles that explain how different LDAP-based attack works. Some of them are decal attack, DSL attacks. There's this nice mind map that the hacker created that basically shows you different LDAP permissions and attributes and what type of attack you can actually do with that. So there's a lot of things that you found up behind the scene. And just one last thing. So easiest way, if you want to learn a little bit more about LDAP, easiest way I found is just ldap.com, kind of easy to remember. You have all of the reference here. So if you go, for example, to learn, you can go to operation types. You have all the different operations that you can do using LDAP. So again, add, compare, delete. You can take a look at search, for example. So this describes different parameters that you can use when you're doing a search operation. So for example, search scope basically specifies what is the scope of the search. So if you look, again, go back to the fact that it's a directory-like structure, we can tell it, okay, I want to search only on this object or only this object downwards or the entire domain. So this is scope, this is what scope means. Also, for example, filters. So when you're doing a search, if you think about a SQL search, you have select star from something where age is larger than 18. Filter is kind of similar to LDAP. Basically, you can do these types of where queries. The syntax is a little bit weird, but it's not too bad. So this is a great resource just to learn more about LDAP.
Okay, so we talked about RPC LDAP. If we haven't convinced you in the first demos that the tech service is huge, hopefully this also helps you understand like why you have such a large attack surface. And let's dive into the tools themselves. First, the RPC firewall. As we mentioned, it's an RPC firewall. Open source, you can get it in our GitHub Zero Networks RPC firewall. You'll find there all of our open source tools. I would recommend also going over, we have a lot of documentation here. We have links for blog posts, other Black Hat talks. We have a Slack channel called Zero Labs, so you can join it, and there's a lot of people using those tools. And there's us, you can ask other questions, you can ask other people that use the tools if they have an issue or you want to consult with the community. And most of the stuff that we'll go through here are also documented in this webpage. So if you can go here, and if you want to download it, just go to release, you get the latest version, extract it, and basically you're ready to go. So this is what we already did on our VM with the RPC file. So it's basically a command line tool, and it includes two different modes or models of operation. So we have the RPC filters and the RPC firewall. Can be a little confusing, but simple to understand. The filters is actually built-in mechanism in Windows. So the Windows firewall, it's built upon something called the Windows filtering platform. So the RPC filters are part of the Windows filtering platform. So you can use the Windows mechanism to create RPC filters. There's even a command line interface that you can use, or you can use to do it. There's some pros and cons. We'll go over them in more detail. The biggest con is that it's very buggy, has a lot of issues, and Microsoft basically won't fix it. So the RPC firewall does some of the work of wrapping around this mechanism, so it's not as easy to make mistakes, so we'll get those bugs, but still there are some use cases that you don't want to mess with the RPC filter. And then is the RPC firewall model itself. The RPC firewall is basically a DLL that we inject into the different processes, which way identifies RPC server. And then whenever there's a new function call, we intercept the call, and then we decide what we do with the call. Do we audit it or not audit it? And do we block it or do we allow it? Basically, firewall. This is open source, so if there's a bug, you can fix it or you can fix it yourself. So it's improved. You're not like stuck with the Windows RPC version. So which one you should use? Should you use the RPC filter or the firewall? The rule of thumb is if a process or if an RPC interface is part of a protected process, you want to use the RPC filter because that's the option that you have, because you can inject the RPC DLL into a protected process. Other than that, the RPC firewall is better because it's more granular. It's happening per RPC function call as opposed to interface call. So the RPC filter will just catch it based on the interface. You don't have the granularity of saying, I want to only block opnum number 5 and I want to allow everything else. You have to either allow or block the interface. It does a better job, the RPC firewall, at identifying the source IP, which, for example, the RPC filters fails at identifying source IPs for SMB RPC calls. And with the RPC file, we can do like a wildcard, catch them all, filter or configuration. You can say everything that's coming from an IP, regardless of the RPC interface, allow or block or whatever. If you try to do it with RPC filters, some services can crash and destroy your domain. So the only use case that you really want to use the RPC filters is when you have to and you don't have the option of using the RPC firewall. Okay, so I think I've talked enough. Let's see how that looks like. I'm going to do a demo of like the basic commands. How do we install, uninstall, start and stop? And how do we actually list interfaces and decide what we should do? Should we do the RPC filter or RPC firewall? Let's go to interface.
Okay, skill the balance.
I'm talking. Okay, so now here we have our PC that we attacked before. That's gonna reset everything back up. I'm just gonna stop and uninstall the RPC firewall. We're gonna remove the other firewall.
Add that.
Okay, so we have a folder here. We already downloaded, put the executables and the DLLs there. And like you saw earlier, I have this command line tool, the RPC firewall manager. Yeah. Okay. Good. Okay. So we have the RPC firewall manager. That's the CLI tool. You have a help menu. So shows you all the different commands. So you can see you have basically install, uninstall, start and stop. I want to go over, there's like an advanced option. If you want to do like a research and you want to hook the RPC firewall just on one specific process, you can. So you can just tell it, I just want to put the RPC firewall on the PID, the process name, just put it there. Right now, we'll just go full blown out RPC firewall everywhere, in production mode. And we'll talk about configuration in a bit later. So the first and the most important command is the status command. And just like you guess, it tells you what's the status. And it also breaks it up to the two models. So we have the RPC filters here, and you have the RPC firewall at the bottom. So as of now, nothing is installed, nothing is working. So you see in the RPC filters, we don't have any filters. There is no auditing enabled, so it's not installed yet. In the RPC firewall, we don't have the DLLs installed. So installing the DLLs is basically we throw them in the system32 folder, so it's easier to pick up by all the processes that are protected by the RPC firewall. We have an RPC firewall service, which is not installed. And the service has two functions. The first is persistency. So whenever you shut down the computer, turn it up again, it's there. So make sure the RPC firewall is running. The other purpose is it's monitoring for new processes. So if a service crashed, it's rebooting, or if you created a new RPC service, whatever reason, we detect that, and then we inject the RPC firewall DLL through that service. So you're always like protected. So installation-wise, nothing is installed. You see all the processes that RPC firewall is protecting. It's not installed, so no processes, and you can see the configuration that is loaded here. Okay. So if you want to start install the RPC firewall, what you're going to do is run. Sorry. We're going to run the install command, and after every other command, I recommend just doing the status. So let's see what's changed. So after we install, The only thing that is changing the RPC filters is now we have auditing enabled. So it's a built-in mechanism for Microsoft. So we don't need to really install anything. So we just turn on auditing. So we'll see events when they happen. For the RPC firewall, it just means that we threw the DLLs inside the system.2. We have a service that is installed already. We have the RPC firewall events already configured. So we have a custom event log that we're writing RPC firewalls events to. So it's configured, it's there, but still nothing is happening. It's not protecting anything. So if you want to protect something, what I'm going to do, I'm going to create a very basic configuration that comes out of the box with the RPC firewall. You'll use it with the RPC conf file. This is like the final configuration. We'll explain how we got there in the end, so don't worry about it. But right now, we're just going to create a very basic configuration. Let's say action, allow, and audit true. So basically, allow everything and audit everything. So you can say configuration is a basic text file that you configure the RPC firewall. And now when I'm starting the RPC firewall, let's do the status command once again. And now we'll see that the status has changed. In the RPC filters, nothing really has changed because we didn't configure any RPC filters, we just configured the firewall. In terms of the firewall, it shows us all of the different processes that are protected with the RPC firewall. So we can see LSS, a bunch of other services. We see the certification authority service, DNS. They are all RPC services that we're protecting. And it's also showing us the configuration that we load. So this is the configuration, just like we saw in the text file. So we're just allowing everything and auditing everything. And finally, coming back to the questions of what should I use, the RPC firewall or the RPC filters, you can use the int command. So if I run int, it shows me it's trying to figure out all the different RPC interfaces that are listening on this host. So you see there's quite a bit. And it shows you a bunch of information on each of these different interfaces. And it's only showing you the interfaces that are accessible remotely. So there's a ton of RPC interfaces that are only accessible locally, not over the network. This shows you only the ones that are accessible remotely. It shows you the PID, like which process is actually running this RPC interface. It shows you the protection level. So that's a very crucial parameter that you can use if you want to understand should they use the RPC filters or the RPC firewalls. So you see there's a bunch of different protected processes here. So the WinTCB light means that it's a protected process. So you can't use the RPC firewall, you have to use the RPC filters. You see the binding, that's the actual SMB pipe or port, TCP port that is listening on, and then you have the interface. So that's the actual interface that is being used. So for example, let's see if I get the right interface. Default check, you can see this process 680. This is a protected process. The name pipe is NTSECS. Maybe it gives you a hint what it is. And I see the interface here. So we just copy this interface and try to Google it. And we got to a documentation just like we got before, Microsoft, that tells us about this RPC interface. You can see it's the Service Control Manager remote protocol. Basically, it's the RPC interface that allows me to create and manage services. So if somebody get access to this interface, they can create a remote service. And this is exactly, for example, what PS exec is using to create a remote service and run some code. So it's a very useful command if you want to understand what's going on and which interfaces it should protect with the filter versus the firewall. Okay. Questions so far? Yeah. Yeah. So normally, I think out of the box, you get out of the box is there's the service, which is running as protected. And I'm not sure what this one is. You can see it here. So 680, I would guess, is the service. And this one, I'm not sure what it is. Maybe it could be the win in its process. So you get all the shutdown interfaces are exposed over that process. Sometimes if you're running the LSAS is protected, it will also be listed there. Okay. So we talked about RPC, we saw the demo. Let's talk about how we can configure the RPC firewall. As you saw, it's a very simple configuration, just text file. And these are the different parameters you can control with this text file. I explain each one here, and we say who supports it. So the RPC firewall basically supports everything. Some of them are supported by the filter mechanism. So for example, opnum, that's like the function number that you saw. So you can create a rule that says you apply that rule, and this is the condition that says only apply this rule if opnum matches whatever you give it. Verbose is used for debugging. We'll also see this in the next demo. Protocol says which transport protocol is used for RPC. So if you go again for Microsoft implementation, you see there's a lot of different ways that RPC can go over the network. Usually you would see TCP or named pipe or SMB, but there's a lot of other weird stuff like MQ, HTTP, IPS. So almost any protocol can move RPC on top of it. There's the address, so you can say apply this rule only if the client is the specific IPv6 or address. You can also give it a range, the CIDR range. I would recommend not to use this at all with a filter model because it gets kind of sketchy, doesn't work all the time. And if you give it an IP range, it gets weirder, so it doesn't really work. UUID, this is the header of the RPC interface that we saw before. And then you basically make a decision. The action, allow or block. Do you want to allow this connection or block this connection? And you have audits. Do you want to create a log or not create a log? And we can audits in our next section. You can also create rules based on the security identifier. So you can say this user can do this operation, or if you're a part of the group, you can do an operation, otherwise not. And that's basically. So regarding auditing, like I said earlier, we have basically two different logs that we use for our RPC auditing. We have the built-in security for Windows, so events number 5712. They are generated when you're using the RPC filter model. And the other one is the RPC firewall is custom events that we're creating. A little bit more user-friendly, I would say. You get more network information. It's more granular, so you can see like the specific opnum that's being created. You can see the seed, you can see the authentication level in text instead of in numbers. So it's a little more user-friendly. Okay. So now we're going to talk about configuration, how that works, and how you can configure your RPC firewall. We'll talk about how auditing works, what is root precedence, how you actually create a filter rule versus a firewall rule, and how we can do some debugging. That's good. Interview. Okay. So right now, basically, we have a uh, very basic configuration. We're auditing everything and we're allowing everything. And for example, if we go and try to create an attack that we did before, so let's, for example, run the at exec. So this is an attack we ran before, it was blocked, but now we're just auditing, so we won't, we're not expecting for it to be blocked. So you're already seeing, like, if you saw the first demo, at first I got like access denied, so now it's running, and I get the results. So I ran against the DC, I ran the system info command. So here, and I got back the host name, which is the DC 2019. So I ran it against the DC, and now I can actually see the information from the domain controller. So the attack worked, and because I'm not blocking anything in the opposite firewall. Okay. So if I want to go and look at this attack and look at the audits, I can go to the actual domain controller. I can go to the Windows events. Application and service logs. And the RPC firewall is configuring the RPC. It's creating a log here, and that's where all those different events are being written to. So for example, if I'll go, let's just randomly look for this UID. I know this UID is related to the at exec RPC interface. I'll try to find it. You can see I came across this log, and it shows me exactly what is happening. It tells me, okay, the at SVC service named pipe was queried. This is the client address that I use to make this RPC call. It shows me the interface ID, which is the interface ID for the attack scheduling attack. I'll go with it in a second. It also shows me the operation number. So it shows me the actual function that's being called. You can see I'm using my Sagi admin account because I'm a local admin. It shows me the SID and some other information about the connection. So I have a full audit of all the RPC connections that are being made. If I'll go, for example, to Chrome, and I don't know this interface, I'll try to look it up. You see, this is the, I think you'll see it here, this is the task schedule interface. So that's the interface that I use to create a scheduled task, run it, get the information back, and so on. So that's how you create like the most basic auditing rule. So now that we know the interface, let's create a block. How do we, I don't want anybody to run this attack against me in my environment. So let's create a rule that stops this kind of attack. So I'm just going to copy it because it's going to take me a while to copy the interface. And to do that, I just need to go to the config file. Let's go to configuration file, let's edit it. Let's add a configuration that says, if the interface is this one, which we saw relates to scheduled tasks, please action block. So hopefully once I get this configuration loaded up, it's supposed to block the attack. So if I want to load this up, all I need to do is run the update command. And that worked. After the update, I run the status command. So you will see a new configuration was loaded. So the update worked okay, and I have a block over this interface. So now let's go back to my client. I'm going to run the same attack again. And you can already see that something is wrong. It's still working. So what the hell went here. So I created a rule, but for some reason, I'm still getting the attack and I'm blocking it. And the reason it's work is very simple, is because how the firewall works is from top to bottom. So the topmost rule is that it matches in rule from the top to the bottom. So if you get a match here, which matches basically anything, it will allow everything and it won't even get to this rule. So if we want this to work, all we gotta do is change places. Let's take this line, let's put it over here, and save it. We'll update the firewall, we'll run the status command. You see the order has changed, so everything should work now. And let's run this attack again. Now we got access to it. So the RPC firewall works, that's great. And what I want to do now is I also want to stop PSExec. So I already know that PSExec looks like this. This is the UID for PSExec. So I'm going to create another rule. And this is my new rule. It's very similar. It just says, okay, if you counter this UID, and this UID relates to the remote servicing RPC, I want you to block it. And it's in the top row, so it should be caught. And I'm going to run a PSExec. No, I didn't do update. Okay. Let's do firewall manager. Maybe let's put this one. Update my configuration. We run the status command. We have all the new rules here. And now let's run the PSExec attack again. Okay. Here. Okay. I'm running PSExec and it takes some longer than it should. But what you'll notice here, it actually worked. I'm on the DC. So what the hell happened here? I'm protecting against PSExec, but it still worked. And it can be very frustrating. If I look at the, let's try to look for this interface, the CUID in my logs, because I'm logging everything. I should be able to see it. So let's search for it here. Trying to search for PSExec, but it's not in the logs. Very annoying. So what happened here? And if you remember in the beginning, we talked about protected processes and other processes and using RPC filters versus using the RPC firewall model. And the reason we can't see the log is that the PSExec is using an RPC server that is running on a protected process. So if we'll go back to our int command, if you remember, that lists all of the different RPC interfaces. Go back to the start. We'll find it. I already know how it looks like. We'll find it here. This is the interface, and it's running as protected. So we can't actually protect it with the RPC firewall, and we can't see any logs because we can't load the DLL into there. So how do we still protect it? Very simple. Just go back to the configuration. And instead of creating a firewall rule, create a filtering rule. So if you have an FLT, it creates an RPC filter. So let's update our configuration. Let's run the status command. Now you'll notice over here, we only have the RPC file configuration from the scheduled task. And up here, we have the filter rule. So you have it divided in the status command. And now, hopefully, if we did everything right, we run the PSExec again. And this time, we should get eventually an error that says access is denied. So make sure to remember you do like the RPC filters whenever you have protected process. So that's basically it. That's how you configure the RPC firewall, and that's how you distinguish between filters and firewall rules. If you want to do more advanced debugging on the tool, you can add a parameter to the configuration file that says verbose true. And what that does, that's writing debug messages. You can use the debug view, for example, from system internals to see all these different debug messages. Now, for example, if I will do RPC firewall, let's stop, and then let's start. For each process that has the RPC firewall, you see all the different debug messages. So then you can understand what's going on, which function is being called, what are my RPC interfaces in each of the processes. You can edit the code and then do all debug messages to better understand. So it just makes debugging a little bit easier. If you want to debug the actual RPC filters, you can use Microsoft command from the net shell command. What that does, that shows you the RPC interfaces that the RPC CLI configured. So here, for example, you can see the description of the filter, and the description is basically the configuration line that we use, so you can understand which filter relates to which configuration line. And you can see the condition here. So you can see it's a match filter, and you can see the condition here of the UUID. So it helps you understand like what's going on behind the scenes. So question? Yeah. Yeah. We done the RPC firewall open source exists for I think almost 3 years now. So we deployed it in many places. We only got the shit in Slack from performance overheads and fixed all performance issue. Right now, I don't think you get almost anything noticeable. So we've run it for weeks and months, so you shouldn't have any performance issues. Yeah, yeah, you shouldn't get any like the amount of RPC calls happening any second in each domain controller is hundreds, if not thousands per second. Yeah. Probably around a dozen DCs more or less with, I don't know, somewhere 5 to 10,000 endpoints, I would say. Somewhere between 5 to 10,000 endpoints, I would say. Not sure exactly, but yeah. I think you're asking if there are false positive in the configuration, like you're blocking things that shouldn't be blocked. So I think you're asking about the I can't hear you, right? So I'm guessing your question. Let me know if I answered the question. We created, we'll talk about this like closer to the end. We create different templates. Again, based on our experience from the deployments that we've done. So we see like what's the normal RPC activity that you should expect. And we know what to block, what's like the irregular stuff that you expect. But you can tune it and configure it as you go. You can audit things and say, okay, this is unique to my environment. You can open all the things that are unique to your environment. Yeah, out of the box, don't go out and block everything. always start with an audit, and when you do an audit, you can say, okay, I know the good things, I can audit, I don't need to audit the things that I know of, then audit the rest of the things, then see what you're left with. And then you know how to do it. Yeah. Yeah. Yeah, and the concept, this goes back to the concept of self-defense. We assume that if somebody got to the DC, sure, they can mess up the RPC firewall, but who cares on the DC? You wanna protect it from network attacks. As long as you protect from network attacks, you're protected from potentially other compromised assets. But if they're on the DC, I guess this is the list of your worries. I think I'm done with my demo. Right? I think it's demo time.
We can switch between that. Okay, for LDAP firewall, again, kind of similar. We have our repository. By the way, we have a bunch of other open source tools if you want to check it out, which is focusing on these two today. So we have our LDAP firewall. It's all open source. If you want, you can check out the code. We have a bunch of useful resources here. So a bunch of blog posts we created introducing the tool, explaining, yeah. Is it better? Cool. A bunch of different blog posts about how to use the tool, how it actually works, like a technical deep dive, a bunch of configuration examples of how to stop like Bloodhound-like attacks and stuff like that. We're going to release a few more blog posts in the near future about more configurations. And all of the like how to use the tool, which we're going to cover today. But if you ever want to go back and learn about it again, you can always find it here. And exactly the same with RPC firewall. You just go to the release page, download it, zip, unzip it, and you're good to go. Yeah, and basically what LDAP firewall lets you do, two simple things. One is audit LDAP operations. So out of the box and windows, you can't really audit LDAP with. So not only you get all of these parameters, so if somebody does a search operation, you can see somebody did a search operation, starting from this DN, asking for these attributes, and so on, but also you get the user that asked it and the client IP, client port. And of course, lets you allow or block the operation based on a bunch of different parameters. Maybe I'll quickly show it. So we have all of the files here. So this is LDAP firewall and RPC firewall. So if you download just LDAP firewall as files, we have the config.json, which is just the rules configuration. We have the LDAP firewall manager, which is the CLI, and a bunch of other DLLs that we use. So we can run the status command, which is usually the first thing you want to do. Maybe even before that, you can run help, actually. And it's kind of simple. You have install, uninstall, update to update the configuration, status, and validate is just to validate it because it's a JSON file. You have the option to make sure like the JSON format is correct. So again, if you look at the status command, you can see that LDAP firewall is currently not installed. And most importantly, this green line here says it's ready to install. That just checks a bunch of like prerequisites, making sure it's able to be installed. And green means we are ready to go. And we'll see that in a second. Once you actually have it installed and you start auditing things, kind of again similar to RPC firewall, you get a new event log under application. This is an example of an operation that you blocked. So you can see at the top LDAP add operation. You can see the user that performed this request, see the action was blocked, all of the parameters at the end. So in this case, we try to add a new object at this path. Entry list is all of the attributes that we wanted to add to this object and the IP. So maybe let's just jump into how the tool actually works. So we go back to our VMs. So first thing, let's take a clean configuration. Okay. Yeah, so let's just take basic configuration, which is kind of similar to what you get out of the box when you're done with the tool. So we can see here that we have basically a rules array, and this is rule number 1, this is rule number 2, this is rule number 3. Again, similar to any other firewall you probably use. And again, rules precedence. So if one of the rules matches, whatever we specified in that rule happens. So in this example, the first rule is basically says if somebody searches for one of these attributes, so admin account, user password, and so forth, we just want to audit this. So these are actually attributes that Platinum asks for. In this case, as I mentioned, we first want to just audit, make sure we're not breaking anything. So we just audit these searches. Next rule says any other search we don't want audited. And the reason for this is because there are a lot of search going on behind the scenes and really load up your events. So just by default, we don't want to audit all searches, and anything else, just allow it and audit it. So add, modify, delete, all of that will be allowed and logged. This rule is kind of not really needed because that's default behavior, but it's just here to make it a little bit more clear. So let's actually take this configuration, go back to our VM. We'll go back to this configuration later, but let's start with something simple. And first thing we can do, actually just run the validate command. Just checks that the JSON format is correct. Again, you don't really have to do this because whenever you install or update config, it automatically checks it, so you won't break anything if your format is wrong, but it's just useful to have if you just want to check it before you do anything else. So let's start by installing. Cool. Now, once we have it installed, first of all, we can go to services. You can see that we have a new service for LDAP firewall. This is how we can actually stop and start the tool. It will also start up automatically when Windows starts up, so we don't have to worry about. Oops, sorry. So if you just want to stop the tool without actually uninstall it, you can just stop the service, start the service back when you want it again, and that's how you can interact with it. We can also check out the event log. And we have here LDAP firewall. And we can see that our first log here is LDAP firewall installed. Basically means everything is running. Cool. Okay, so next, one useful way to create LDAP requests is a built-in tool in Windows called LDP. It basically lets you do LDAP queries. It comes pre-built with a lot of Windows versions, not all of them, but if not, I'm sure you can find it online. Basically, what you do is connect, then you bind is basically login. So now I'm authenticated, and now let's do a search. So let's do a very simple search. What we're going to do here, basically tell it, start from the top of the domain, object class equal star is kind of like select star in SQL. So just give me everything and give me, just run it. And basically what we get is all of the objects in my domain. So for example, we have here admin Segi. This is the user account, all of the different attributes. You can scroll up and see just a regular account and all of the information that we have. And as we mentioned, this type of search will not be long, but if we do something kind of like Bloodhound does and ask for the admin account attribute, it will go through because we're just auditing. And if we go to our event here, Redshift, yeah, and we can see here the search. So the search was using the admin account attributes, the IP, all of the information. So now it's actually auditing this request. Now, let's say I want to actually block it to stop things like Bloodhound from working. Just go to our config JSON and simply add to this first rule action block. Now, all we need to do is update. Takes a few minutes. Oh, and now we can do the same thing. So let's start fresh, connect again, we bind again. That's where I messed up the credentials. Cool. And let's do exactly the same search that we did. So the same thing using the admin count, run it. And now you can see here getting 0 entries. So exactly the same thing. Only thing is we changed the rule to be a block rule. So now we don't actually getting any result because somebody asked for this attribute. Yeah. For which of the things? But basically, yes. It depends on the parameter. Yes. Yeah. Yeah. So it looks it's a substring, so it looks if it's in anywhere in the network. Yeah. Yeah. Not for that specific. Are you worrying about what collisions or what? Are you worrying about like collisions or what? Not if that tool specifically I haven't. Yeah. Okay. So next up, let's check out debugging. So in order to get actually debug logs, we can just add debug on. So it's not actually part of the rules array. Just, another line, debug on. Are they? Run it again. And now we can see that we'll have a new file called l.firewall-log. So most of this is honestly more useful for me as a developer, but might be interesting for you to see. So first thing you can see that we can see what configuration was actually loaded. Let's see if I can. Yeah, and then there's a bunch of verbose information about how the LDAP messages are actually parsed. So we can see, for example, here we received our message, we're parsing everything, and at the end, we see that the rule was hit. So in this case, rule number one was hit, which is this rule, because we have this attribute admin count. And this is how we can actually see why a specific rule was hit. So if we go later to another search request, in this case, rule number two was hit. Now we can see all the different parameters for the search, like the DN and all of these things. We can compare it to our configuration. So in this case, this rule number two, and this is why the first operation that was was allowed, sorry, was blocked, and the second was allowed. So if you have configured something, not really sure why a rule was hit or not here, or why some rule taking precedence above another rule, this is just one way to validate that. Now, maybe we can look at more real-world example. So we can take this config file. Okay, so this is kind of like a more real-world example. Do you need me to zoom it, or can you see it okay? Sure.
You have all these examples also in the GitHub repository, so you can find them.
Yeah, so for this example, first rule is if there's any local activity, again, this happens a lot, local LDAP on this itself. So we just allow it again, first of all, because it happens a lot. Second, because if the attacker is already on DC, it's probably not as relevant. You can add here also IPs and stuff. So if you have like IT management, like infrastructure management servers, chunk servers, things like that that you use to manage DCs, you can add them also here to allow those. Then we have block, so block for specific searches, like Lala. Then we have blocking any modify operation that tries to modify one of these attributes. So this attributes is taken from some of the resources that I gave earlier. So these were actually identified as attributes that are used by attackers in different attacks. So basically block all of these modifications. Then we block any ads. And as always, we don't audit regular searches and we allow everything else. So let's just take this as an example. Once again, do an update. And now let's try to do something else. So for example, let's try to do an add. We can just take my DN component. So let's imagine I want to add a new object under my domain. So for example, let's say common name equals attacker, and this is a new object that I want to add under my domain, and we'll do attributes and data, and I'll just try to run it. So again, in this case, you'll see that you get insufficient rights. So this is the default error message that LDAP firewall gives you. So basically, it means we try to add it. We're using a really high privilege user, but we still can't do it. Now, in the real world, you probably maybe do want to have some IPs or some users that are allowed to add objects. So again, if you have get admins or infrastructure management service, you probably want to let them these changes on your schema, but probably most of us in the network shouldn't be able to do these changes. No really reason for them to do it. So what are the different parameters that we have for a rule? So we mentioned already operation. It's an array. Operations basically says for which operation type this rule applies. So we can use, for example, add, modify, search. We've seen that already in the config. We can use star for any operation. IP is the client IP. Again, IP or CIDR range. User is what user like what client user did this operation. We will match. We can also do groups. So if we say our domain admin group is allowed to do add operations, but regular users shouldn't be. So that's how we can do that. At the end, we already mentioned the same. So if we want to block searches from a specific VN, or we want to allow everybody to add, I don't know, objects under a specific VN, but nowhere else, is how we can create that rule. Attributes mentioned already is kind of a specific case. So there's one operation that's called extended operation in LDAP, which is not widely used, but the idea behind that is if you want to extend the LDAP protocol and add custom operations of your own, you can use an extended operation. Then OID is the object ID. Again, not commonly used, but in case you want to use that, we have the option to block or allow based on specific OID. Filter, we mentioned that's used for searches. Scope, also for searches. And then finally, audit and action. So audit on or off, action, allow a block. And obviously you can mix and match that. So you can say, I want to block, but not audit. I want to block and audit, allow, not audit, all of these things.
Okay. So now I guess the big question is, okay, we saw the different tools, we saw how we configure them, but how do you take this into your environment and actually make it work? It can be, it looks like very complicated, but it's not that complicated. And there's a lot of tools and a lot of things that you can use. And we're here for you, that's what I'm saying. And the concept of how do we get from those tools and deploy them and to actual prevention engineering, it's basically a cycle that we discussed a little bit earlier. Start with something basic, audit what's normal, stop auditing that, audit everything else, make an adjustment and go on and so forth. And after a week, 2 weeks, you can create basically a baseline or basic configuration that audits all of the attacks. And when you're feeling comfortable, you can also go to like block mode. So I've run the tool a week now. I'm auditing everything that should be abnormal. I haven't seen anything in the past week or 2 weeks. Now I'm ready to go into block mode and stop all the possible attacks that I can get to my environment. And there's different ways that you can do that. You don't have to start from scratch. We have, for example, RPC firewall templates. So if you would look, for example, at my the configuration that I use in this workshop, which is here. This looks very complicated. How the hell would you do that? Look at all these different UIDs. It's a mess. But everything I did to create this configuration, I just looked at the interface command. If you remember, it shows me all of the protected interfaces. I copied all the protected interfaces and I created filter rules that says, okay, block all these interfaces. Nobody should be contacting those interfaces. That's like rule number 1. Rule number 2, I have my IP, allow everything local for my IP. Rule number 2. Everything else that you see here, open to any common DSSP, I simply copy pasted it from this template. We have a template here called RPC firewall configuration. And this is based on things that we saw like in the wild. We looked at different interfaces, like what are the most common operations that are being called, and what are the most like innocent operations that are being called. So we can allow those and block everything else. most environments, it will work out of the box, but obviously, when you go to the end, I wouldn't block it at the beginning. I would leave it as an audit only and see how that works for a week, and then go into work mode. RPC is pretty simple, I think, compared to LDAP is also pretty simple if you don't look at the search command, because LDAP search could be more hectic. So LDAP is much more easy if you want to block other commands. You also have other firewall templates that you can use. We have also a blog post that talk about how you can use the other firewall if you want to block scanning attacks like Bloodhound and so forth, and how you block LDAP against DACL attacks. So you can use any one of those configurations. Another thing that you can use is all of the logs are written to the Windows events. So if you have a SIM in place, you can simply use that SIM, load up those events, and run some queries, see like what's going on in my environment, and create your baseline and create your configuration. If you want to run this in a lab, or you don't have a SIM, or you just want to make things easy, we have PowerShell scripts. You can also find them in our environment. And what they do is simply take all those events from the firewall and throw them into a CSV file. And then you can just pivot and analyze the data however you want. So if let's run PowerShell, let's run PowerShell. If I'm running the get RPC events, let's stop there. And I can run the get. Get LDAP events. What it does, it simply creates a CSV file over there. Those, then you can then just makes your life easier. You can just open them, then look at all the events in a flat way, create pivot tables, then create roles and create configuration. Just makes life a little bit easier. And same thing for the LD firewall. And finally, we have Sigma roles. I would assume some of you have heard of Sigma HQ. So if you go to Sigma roles, there's a bunch of protections that are already in place for the RPC firewall. So you can use it if you have it in place, you can just throw it out there. We have the same thing for LDAP. Still not integrated into the main branch, but we have a Sigma role in our own repository. That's how you do it. You see the templates, you can ask the traffic, you already have the detection in place. So you have all the tools that you need to basically start running either firewall or RPC firewall in your environment. And that's basically it. Like we said earlier, we have a Slack channel. So if you're you get stuck, you want to ask us, you want to ask somebody else who's using the tools, you can do it with the Slack channel. Both of the tools, you'll find the links in the repo. That's basically it. Now we can do some questions or anything else. Yeah. I can hear you. I can hear you. Yes. It's basically within, like, it's not on the network, so it doesn't matter if it's encrypted or not. Yeah. We haven't, and again, if you're running and you notice anything that,
Yeah,
I don't know,
in the demo, it was,
you can always hit us up and say, hey, I'm seeing this lag when I install LDAP. You know, we do a lot of checks, but there can always be bugs, there can always be issues, but we can always fix those. Thank you.
There any questions from Zoom or? Yeah, there is? Is there Zoom questions or no? Oh. Okay. Sorry? I think we'll ask how we either we put it on Git or yeah. Yeah.